this lesson, I'll do my best to address one of those common errors students make when working with Kirchhoff's laws. That is, the error of not selecting the right direction for their current. That said, let's get into class. Now, like I promised, we'll use this example to understand how to select the right direction for your current. Now, look at it this way. This example, we're going to find the current in each branch of the circuit. Now, I have three lines here. I have current I1 here, I have current I2 here, and here I should have I3. Now, if you look here, you see that I1 has been picked in the direction of this current, so I can write my loop this way. While I2 has been picked in the direction of this current, I can write my loop also this way. Now, along line, if you now look at this, I have I3 here. Now, since I've written my loop this way, I prefer to pick the direction of I3 this way. Now, this will form the basis for my calculation. At this node, this is one of my primary nodes, while I'll take this node here to be my earthing node, which in most textbooks you will actually not see this. But this is my major node here. Now, if current I1 flows into this node, current I3 flows into this node, and current I2 flows away from this node, we know from this equation, we know from Kirchhoff's current law that says that the total number of the sum of the current flowing into the node is same as the sum of the current flowing out of the node. Now, current I1 is flowing into the node, current I3 is flowing into the node, and current I2 is flowing out of the node. That is, I1 plus I2, I3 is equals to I2. Now, for my first loop, here's my first loop. Here's loop 1. For my loop 1, I can deduce that my voltage 4 volts, the sum of the voltages, the algebraic sum of the voltages, that is the 4 volts plus the 12 volts. Now, why am I adding them together? If you look at it this way, I have my positive here, then here is a negative, so that my current should flow this way and is in line with this loop. It will equals to the algebraic sum of the voltage drop across the individual resistance. Now, across the first 0.5 resistance, I'll have the voltage drop will be 0.5 times I1. Now, plus the voltage drop across the 2 ohm resistance, that's this resistance here, that will be 2 times I2. So that invariably, I'm saying that 4 plus 12, that's 16, is equals to 0.5 I1 plus 2 I2. Now, let's take the second loop. On the second loop too, I have just one voltage source in this loop. I have just my 12 volts across the loop. That's 12 now, will be equals to voltage drop across my 2 ohms, that's 2 I2, plus the voltage drop across the 5 ohms resistor, 5 I3. Now, but I don't want to use I3 since I'm just going to use two equations to make my equations easier. I can pick my I3 from my current law here, so that this my I3 should be the same thing as I3 will be the same thing as I2 minus I1. So that from loop 2, I can conclude that 12 is equals to 2 I2 plus 5 into I2 minus I1. So that 12 now will be the same thing as 2 I2 plus 5 I2 minus 5 I1. So that 12 will be the same thing as 7 I2 minus 5 I1. Now, I can tag this my equation 1, while I tag this my equation 2. Let's write both of them together. Here I have my equations. I can see that equation 1 has 0.5 as the coefficient for I1 and equation 2 has -5 as the coefficient for I1. That means I can use the elimination method to quickly solve this problem. Now, I'll multiply equation 1 by 10 and add both equations together so that I'll have my equations now look like this. 16 is equals to 5 I1. I've multiplied 16, this is by 10, that's 160, plus 20 I2. Then equation 2 should be 12 is equals to -5 I1, I'm rearranging, plus 7 I2. Now let's sum these equations together. 5 minus 5 becomes 0. 160 plus 12 becomes 172 is equals to 27 I2. Divide by 27. We divide this by 27. So that I2 obviously is equals to 172 divided by 27. From my calculator, 172 divided by 27, that's 6.37 amps. So my I2 is 6.37 amps. Now, conveniently, we should be able to solve for I1. Let's use equation 1. Equation 1 says 16 is equal to 0.5 I1 plus 2 I2. Then I can substitute 6.37 here. So that's 16 minus 2 times 6.37, 12.74 is equals to 0.5 I1. Now, that is 3.26 is equals to 0.5 I1. Let's divide both sides by 0.5. We divide this also by 0.5. So that I1 will be the same thing as 6.52 amps. Now, if I1 is 6.52 amps and I2 is 6.37, then we should be able to deduce for I3. Remember, we said that I3 is equal to I2 minus I1. So I'll be saying that I3 is equal to I2 minus I1. I3 will be the same thing as 6.37 minus 6.52. That is 6.37 minus 6.52. I3 is equal to minus 0.15 amps. That tells me that the direction I took for I3 was wrong. So, because why? It has a negative sign. I can easily go back to my circuit and change this direction. But in any examination situation, the examiner knows if you get the negative answer, he knows you only selected a wrong direction. No one will penalize you for that. That said, thank you for staying with us and see you in our next lesson.